method. In this video I will be teaching you how to solve a question of titration using the equivalence method, which I can say is a easier method when we compare it to the mole method. So let us tell you the question. A solution of mixture of KCl and KOH was neutralized with 120 ml of 0.12 NaCl. The normality of the acid is given. Calculate amount of KOH in mixture. This is the first question, and then the second part is given that after titration the resulting solution was made acidic. Then excess of AgNO3 was added to precipitate AgCl, which weigh 3.7 grams. Calculate the percentage of KOH in the original mixture. This is the second question. Here I have written the equation KCl and KOH, the initial mixture, and in it we have added HCl. So KCl is a salt, so it is obvious that the HCl will react only with KOH, and when HCl will be reacting with KOH, what will it be giving? It will giving KCl plus H2O. Now in the mole method you would have to write even the H2O here, and you would have to write all the products. But in gram equivalence method that is not important. From gram equivalence method we can write that 1 equivalent KCl reacts with 1 equivalent KOH to give 1 equivalent KCl, and this react with 1 equivalent HCl. So friends, the formula for number of equivalents is volume in liters multiplied by normality. Here as you can see that the volume is given in milliliters. I would prefer to use milliequivalents here. So milliequivalents is volume in milliliters into normality. Volume in milliliter of HCl is given 120, and the normality it is given 0.12, so it will come 144, and 144 we will be adding this 0 and we will shifting 2 points, so it will come 14.4. These are the milliequivalents of HCl used here. So as I have written, then 1 equivalent KOH reacts with 1 equivalent HCl to produce 1 equivalent KCl. I have written here new KCl because first KCl is here, which is originally in the reaction but it is not taking part in the reaction, and this KCl is formed from the reaction of KOH and HCl. So here the milliequivalents of KCl new we can write from the equivalence theory that it will be equal to 14.4 milliequivalents. So what we have to calculate now? Calculate the amount of KOH in the mixture. So HCl has reacted with KOH, and I have written that 1 equivalent of HCl reacts with 1 equivalent of KOH. This equation we will be using in the later part of the question, friends. Let me highlight it. And from here we can easily calculate the milliequivalents of KOH also. Milliequivalents of KOH is equal to milliequivalents of HCl, which is again equal to 14.4. And so now we have the milliequivalents of KOH. Now my friends, there is another formula that the milliequivalents is equal to the millimoles into the N factor. Now as we can see here that the KOH is a monobasic acid. A monobasic acid means that it has an N factor of 1 as it has one replaceable OH ion. So here we can say that the number of milliequivalents is equal to the number of millimoles, which implies that millimoles is equal to 14.4 into 10 raised to the power minus 3. And friends, now from moles it is really easy to calculate the mass. I have added 10 to the power minus 3, it will be moles now, and it is really easy to calculate the mass from moles. the mass of K is 39. K is 39, and one oxygen and one hydrogen will make 17, which means it has a mass of 56 grams per mole, which implies weight of KOH will be equal to 14.4 into 10 raised to the power minus 3 into 56. Here, my friend, I have a phone for my aid to do the calculations, and I will be multiplying 14.4 with 56 here, and the answer is coming 806.4. So it will be 806.4 into 10 raised to the power minus 3. So it will be coming 0.8064 grams of KOH is in the solution, and here comes the answer to our first question. So my friends, now we'll be solving the second part of this question, and the second part, it is given that after titration the resulting solution was made acidic. Then excess of AgNO3 was added to precipitate the AgCl, which weighed 3.7 grams. Calculate the percentage of KOH in the original mixture. Now here I have written down the equation, that is the KCl reacts with AgNO3 to give AgCl. Now as it is not the mole method and do not need to write the whole equation and thus balance it, we can simply write according to the equivalence theory, that one equivalent KCl reacting with one equivalent AgNO3 and giving one equivalent AgCl. Isn't that easy, friends? And we have been given that the mass of AgCl which will be precipitated is 3.7 grams. We know that the molar mass of AgCl can be calculated as 143.5. So the moles of AgCl can be calculated using the given mass upon the molar mass, and it will come the moles. I will be taking again the aid of my phone to get the answer, and here we will be dividing 3.7 divided by 143.5. It is coming 0.0257. 0.0257. Now in the whole questions we are talking about millimoles, so we will convert it into millimoles. It is the millimoles, as the number of millimoles is equal to the number of moles multiplied by 1000. And now my friends, in a salt like AgCl, the N factor is given by the total number of positive charge per atom or the total number of negative charge per atom. Here, as it is AgCl, both have valency stable electron Ag plus and Cl minus. So here the N factor will be 1, as there is only one charge on a single atom. On Ag it will be plus 1, and on Cl it is minus 1. So the N factor is 1, and according to the formula which I had taught you earlier, we can say that the millimoles of AgCl is equal to milliequivalents of AgCl. Why? Because the milliequivalent is equal to millimoles into N factor, and as the N factor is 1, it will be equal to milliequivalent, which implies that the milliequivalents of AgCl is equal to 25.7. So now my friends, this is the tricky part of this question. I would like to say that here I have written the KCl, but will this KCl with the KCl which was initially in the reaction? No, my friends. It will be this KCl plus the KCl which was created when KOH reacts with HCl. So now from here we can write that milliequivalents of KCl old of the KCl that was already in the reaction plus milliequivalence of KCl new which was formed after it reacted with HCl is equal to 25.7. So as I have told you that we'll be using this later in the question, the milliequivalent of KCl new is equal to 14.4. We'll be using it here to calculate the milliequivalence of KCl old. So we can write that the milliequivalence of KCl old is equal to 25.7 minus 14.4. Will again be, I have substituted my value here, so the value which will come here is 11.3. So now again we'll be here, we can again see that the total number of positive charge or negative charge per atom is +1 or -1. So we can again write that the millimoles of KCl is equal to 11.3. Now if millimoles are 11.3, which implies moles of KCl is equal to 11.3 into 10 raised to the power -3. Now 10 raised to the power -3 will be multiplying it with the molar mass, and we'll be getting the mass of KCl in the mixture initially, which implies mass of KCl initially in mixture is 11.3 into 10 raised to the power -3 multiplied by its atomic mass, which will come K has an atomic mass of 39 and chlorine has 35.5. It is coming 0.5, 9 plus 5 14, 74.5. will multiply it by 74.5. Once again phone comes to my rescue. This time we'll be multiplying 74.5 with 11.3. So friends, here we are getting 841.85, which implies mass of KCl old, which is initially in the mixture, this is equal to 841.85 into 10 raised to the power -3, which is equal to 0.0841. So now we have got the mass of KCl and we have got the mass of KOH earlier. I will write that here, mass of KOH, which is equal to 0.8064 grams. Now we can easily calculate the percentage of KOH in the mixture, which will be 0.8064 upon 0.841 plus 0.8064 into 100. So now it will come coming 1 upon 0.8064 divided by 1.647 into 100. Once again I'll be using calculator here, and I'll be dividing 0.8064 with 1.64, 64 divided by 1.647, and we are getting 0.489, which will be multiplied by 100 to give 48.9%, and this is the final answer. So in this way you can calculate the question. We can analyze the question using the equivalence method. If you don't know how to balance the equation, you can easily use this method. If you just have to write the equation half if you want, and you just have to equate the milli equivalents. Here first we found out that the milli equivalent of KCl nu was 14.4, and the milli equivalence of KOH also was 14.4. Then we use the formula that milli equivalence equal to millimoles into n factor of KOH, as it is a base and it has only a single OH replaceable, so the n factor will be 1 here. So the weight from here we can found that the millimoles is equal to the milli equivalence, and the millimoles, so the moles will be equal to 14.4 and 10 to the power minus 3, and the weight of KOH will be coming when we multiply it from its atomic molecular mass. From here we get that the weight of KOH is 0.8064, and here the first part of our question is solved. The second part of our question will again write the equation. Don't worry if you don't know how to balance it. And then again you are given with the mass of AgCl. From there we calculate the moles of AgCl in the equation. From here we know that the millimoles of the equation is 0.0257 into 10 raised to the power 3, and the millimoles of AgCl AgCl is equal to the milli equivalence of AgCl, again because of the formula that the milli equivalence is equal to millimoles into n factor, and as AgCl is a salt, it has only one electron negative charge or positive charge per atom. So the milli equivalent of AgCl we found out from here 25.7, and as we know that the KCl which will be formed in this reaction will be both from the old one and from the new one, which will be formed by the reaction between KOH and HCl. So we can write milli equivalent of KCl old plus milli equivalent of KCl new is equal to 25.7. We subtracted it, we found out the milli equivalent of 11.3, and after that it is the same repeated process. So friends, I hope you like my video. Like, share and subscribe my videos for more. Thanks. Keep watching the Chem Nerd. Thank you.